Jayashree, is my screen visible?
Yes, ma'am. Ma'am, am I visible to you?
Wait, let me check. Yes, you are visible. So, good evening, everyone. I'm Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL, whose course instructors are Professor Harinath Chagrapani and Professor Neeraja Dashaputre from ISER Pune. In week 4, we are going to cover carboxylic acid and its derivatives with the introduction of some questions based on alcohols, ethers, and epoxides. So, this is problem number 1. First, you have to solve, and then I will tell you solution for this. Okay. So, the correct decreasing order for acid strength is. Jayashree, can you tell me how to solve these type of questions?
Ma'am, we will basically check the stability of the conjugate base,
Exactly. And then
and then we will see which of the conjugate base is most stable, and
exactly.
that acid will be the strongest acid.
Yes. Yeah. Wait. So you are saying, let's say we are having acid Ha. Okay. It will undergo dissociation H plus A negative. This is your conjugate base. According to Arrhenius theory, more stronger is the acid, more it will give H plus, right? When
Yes,
it
ma'am.
when it will give more H plus when its conjugate base is going to be stable. So if we draw conjugate base for all these, we will get CH2F, COO negative. In case of nitrile, we will get CH2, COO negative, and in same way we will get other conjugate base, as you said. So Jayashree, can you tell me here fluorine have which effect? We have mainly three effect, that is mesomeric,
Yes, ma'am. Inductive.
hyperconjugation, and third one is inductive. And we know that in case of halogens, which effect dominates? Minus I. So fluorine is having minus I effect. Can you tell me CN is going to show which effect?
No, I'm sorry, I can't remember it properly. I think it's hyperconjugation.
No. Nitrile is having minus M group because let me explain why. Wait. Let's say if you have nitrile on your benzene, okay, nit so your nitrile is like this, sp hybridized, right?
Yes.
So for resonance, this can't give its electron to benzene ring. Rather, it will take electron from benzene ring, right?
Yes.
So therefore, whatever group is attached to benzene ring, if it is pulling electron density of benzene ring, it will show minus M effect.
Okay.
Understood? So Cn is
Yes,
showing
ma'am.
minus M effect. NO2 is also showing minus M, and chlorine is again minus I.
Yes.
So now it comes about order, or we can say that power of minus M and minus I. So you should remember NO2 have more minus M power than cyanide. Okay. And minus I effect of fluorine is greater than chlorine. Why? Due to high electronegativity of fluorine. Okay.
Yes.
So according to you, in this carboanion means there is electron rich center, right? So to stabilize this carbanion, we have to attach group which can pull its electron density, right or not?
Yes, ma'am.
So for that, minus m has greater power than minus I. So if we see order, NO2 should come first, then nitrile, then your
Then
fluorine, and at last your chlorine. Here they are asking decreasing order of acidic strength. So first it should come NO2. So option number 1 and 2 gets cut. Among 3 and 4, here in fourth option fluorine is coming before nitrile, which is wrong. So option 3 is most appropriate. Have you understood?
yes, ma'am.
Okay. Do you have any pre-knowledge of reducing agent, oxidizing agent?
Yes, ma'am. I do.
Okay, okay. So problem number 2 is based on reducing agent question. When CH2 double bond CH C double bond OH is reduced with LiLH4, the compound obtained would be first is allylic alcohol, second is your propanol, third is your propanaldehyde, and fourth is your propanoic acid. So according to you, which option should be most appropriate?
Ma'am, I think it will be the option 3.
Okay, you are saying double bond will reduce and this acid will get converted into aldehyde.
No, ma'am. I'm sorry. I think it will be the first option.
Exactly. Because LAH is very okay,
I,
one LAH can give how many hydride? Can you tell me?
I think it's 1.
See, if we break LiAH4, it will become like this, right?
Yes.
Let me explain from basics. This is your AlH4 negative. Okay. We know aluminium is from which family? Boron family. Okay. Boron is happy in forming three bond only. So anyhow it want to become three. So let's
3.
say we have carbonyl. Okay. So first your lithium plus is going to coordinate with carbonyl, right? Now electrophilicity of this carbonyl group has increased due to chelation of lithium with oxygen. Now this aluminium has four bond, so it will donate one hydride to this, and it will result into formation of OLi and hydrogen. Understood?
Yes, ma'am.
And it will become AlH3. Okay.
Yes, ma'am.
AlH3 now again become electron deficient because if you know boron have 1s2, 2s2, 2p1, right? After having three bond also, let me draw it this way. This is 1s2, 2s2, 2p1. Let's say after excitation, so boron can form three bond, but you can see that one of the p orbital is still empty, right? So this O negative is going to attack here, AlH3. Now again, what charge will come on this aluminium? Negative. There is one problem with this aluminum. When it is having three bond, it is electron deficient due to this vacant p orbital. And when it is having four bond, it wants to donate its hydride to become three. Okay. Have you understood till here? Or I
Yes, ma'am.
should explain again. Okay. Now we
No,
have
ma'am.
another molecule of ketone in our medium. Okay. So it will give wait. Hmm. So again it will give its hydride to this molecule, and what it will form? This one. correct?
Yes, ma'am.
So in this way, LAH can reduce ketone to alcohol, right? By giving 4 hydride. Aluminium hydride have how many hydrogen attached to it?
4.
So in one go, it can reduce 4 carbonyl groups. So therefore, it is going to reduce your COH to alcohol. Sorry for this. So most appropriate answer is 1. It is not going to touch your olefin.
Yes.
Okay, good. So problem 3 is among the following acids which have the lowest pKa value. Let me tell you, more more stronger is your acid, more stronger is your acid, lesser will be
The pKa value.
exact, lesser will be its pKa value. Okay, so let me tell you how to see acidic strength in order wise. First step is make conjugate base. Second is check. Jayashri, can you unmute your video? Whenever it requires, you can unmute. Otherwise, my voice will come twice. Okay. I'm audible, right?
Yes, ma'am.
Okay. So first step is make conjugate base. Then check stability of conjugate base. And how to see stability? Let me tell you. You have to see in the same sequence. Size, size on which your carbanion has been formed, right? Size of atom. Okay, tell me if you have oxygen and you have sulfur. Among these two atoms, which can hold this negative lone pair easily?
Ma'am, I think it's sulfur.
Exactly. Why? Because sulfur is a big atom. It is having vacant d orbitals. It can it can keep
Whole.
this negative charge and then that will be more stable. So among S
Yes.
negative and O negative, S negative is more stable. First you have to check size, then you have to see electronegativity. Among oxygen negative and carbon negative, which anion is more stable? Oxygen. Why?
Okay.
Because more the electronegativity of atom, more it will stabilize this electronic rich carbanion, right?
Yes, ma'am.
Hmm. Third factor you have to see is resonance. Fourth you have to see inductive. And in resonance, if you have listened, same atom resonance get preference. So now we just have to apply all these rules. So in first option, your carb anion will be like this, or we can say that conjugate base, not carb anion. I'm wrong here. Anion. Okay. Second, it will form HCOO negative. In third case, you have right, and in fourth case, you have CH3, CH2, COO negative. All good. So if you can see that this COO negative is same in all these. So deciding factor is these groups. And we know that alkyl groups show plus I effect. And for acidity, minus M. minus I directly proportional to acidity, while plus plus I and plus M things are inversely proportional to acidity, because in acidity a negative charge is forming, and to stabilize that we have to decrease that negative charge anyhow. And how we can decrease? By putting there minus I and minus group. But here your alkyl group shows plus I effect, and we know that CH3 shows plus I effect. Hydrogen is having zero effect. This is isopropyl. This also shows plus I effect, and this CH3CO2 also shows CH3CH2. That is ethyl group also shows plus I effect. So by seeing looking at option, according to you, which option can be correct
Ma'am,
among
I think it's third option.
third option? But can you see third option? We have 2 degree carbon, right? So this is having more plus I, but to increase the acidity,
Sorry,
what
sorry, sorry.
what groups are preferable? Minus I. Minus I are what groups? Like fluorine, chlorine, your NO2, your CN. These are minus I and minus M group. So this option will come at, see. Question is asking lowest pK
Oh, yes,
means
ma'am, definitely.
highest acidic strength. So among all these options, option two is most appropriate. Have
I'm
you
sorry, ma'am.
understood? No
Yes,
issue.
ma'am.
Okay, this is about correct answer. So can you tell me among first, third, fourth, what will be the order of decreasing acidity? Let me write here. Decreasing acidity order. Can you tell me among one, three, four?
Ma'am, I think
Or let me tell you in advance that 3 degree carbon, 2 degree. Okay, wait, sorry, 3 degree carbon, 2 degree carbon, and your this is plus I order. Can't write by this. Wait. Is there someone who has joined our class? Wait. Okay. So everything has been rubbed actually. So we reached to answer that this is most acidic. Now among 1, 3 and 4, 1 is most acidic, then your third, then 4. Why? Because CH3 is having less plus I than your isopropyl group plus I order. And then there, see, this is your 1 degree, because this carbon is connected to one carbon and this carbon is connected to two carbons. So this is 2 degree carbon and this is your primary carbon. So plus I order is this, and we know that acidity is inversely proportional to plus I. So this will be the order for other options. Understood?
yes, ma'am.
Okay.
ఎప్పుడా
What? Yes, could you please repeat? Hello. So this is your problem number 4. Paracresol reacts with chloroform in alkaline medium to give the compound A, which adds hydrogen cyanide to form compound B. The later on acidic hydrolysis gives chiral carboxylic acid. Then tell the structure of carboxylic acid. Let me explain this question for you. Kindly mute yourself. If you have any doubt, you can unmute. But right now, please mute. Okay. So, so paracrisol is this. First, write step by step. Okay. Paracrisol.
అత్యంత అత్యంత
It is. It is saying paracrisol.
ఆయన
Uh, could you please repeat what you are saying? Wait. Ritesh, what you want to say? Or Bora? Either mute yourself or ask your query. Okay. So this is your paracrisol. It is made to react with chloroform. Can anyone tell me which reaction is this? To give compound A. Okay. Then compound A is made to react with hydrogen cyanide to give compound B. It is saying that the latter means compound B on acidic hydrolysis gives chiral carboxylic acid. The structure of carboxylic acid is. Now, can anyone try this question? Okay, first of all, what we are having in our medium CHCl3, that is your chloroform. In alkaline medium, sodium hydroxide is a base. First, it is going to abstract this proton, right? Can anyone tell me if you know about Riemann-Tiemann reaction?
And I do.
Okay. Tell me what is the product of Riemann-Tiemann reaction?
And I can't remember it properly, but I
At alpha position, CHO will come, okay? And here CH. So in presence of base, this this carbon ion will form and will knock off one of the chlorine negative as chlorine negative, and it will form carbene, dichlorocarbene, right? Carbene, you can treat it like, for simplicity only, you can treat carbene like positive and negative. Negative why? Because base has abstracted its proton and one of the chlorine is leaving from here as Cl negative, so it will leave here positive charge. So positive negative is your carbene. So at first step you have your OH CH3. Okay, this bond is going to come down like this, OH positive, and here carb anion will form, right? Enolate, and it will attack this carbene. Carbene is having two charges, positive and negative. Positive charge has been quenched by carbon ion formed at here, so it will be having negative charge. Now intramolecular proton transfer. Are you getting now what I am explaining?
yes, ma'am.
Okay. It will become your double bond O CH Cl Cl. Now can anyone tell me what will happen here?
And I think the negative charge will push back.
Exactly, and aromaticity will be retained.
Yes, ma'am.
There are actually different mechanism possible for this reaction, but we will go according to this. And here you are having 2Cl. Now you have sodium hydroxide in your reaction medium. It will substitute this chlorine by OH, right? And this, by elimination of water, what will it form? Your salicylic having wait, screen. So your product is OH, CHO, and paramethyl. Up to here, it is clear now.
Yes, ma'am.
Now, can anyone tell me ec- what will happen on addition of hydrogen cyanide, to which functional group it is going to react among these three? This is out of game, right? Among these two, obviously HCN will get added on this carbonyl.
Carbon.
It will form OH, C, OH, CN. Till here it is clear. And you should know that cyanide on hydrolysis gives carboxylic acid. Ah, wait. Cyanide on hydrolysis, if you have RCN, it gives RCOH. This is your homework, that you have to draw a mechanism for conversion of nitrile to acid in presence of acidic medium. Okay, draw mechanism and tell me in next class. So now can anyone tell me which option will be correct among these four? See, this option gets eliminated because there is nothing ortho to OH. In these option 3 also gets eliminated. Now among these two, it is already saying chiral carboxylic acid. This carboxylic acid is not chiral at all. Chiral means your carbon should have four different substituents, A, B, C, D. Here this carbon is having two hydrogen. Okay. So most appropriate answer is B, or second option. So first, in presence of paracrysol, in presence of chloroform and base, undergoes Remer-Temin reaction, form salicylic aldehyde, and then hydrogen cyanide adds on this aldehyde, which undergoes acidic hydrolysis to give acid. Understood?
Ma'am, I have a query.
Okay. Tell, ask.
Then why the first option is eliminated?
Because in first option, your ortho position have nothing. But we know na that Remer-Temin reaction, aldehyde is introduced at ortho position to this OH. But here nothing is at ortho position to OH. That's why.
Okay, ma'am.
Okay. Can we move ahead? If anyone have doubt, you can unmute yourself and ask. I will explain again. Or should I draw this mechanism on different page, if you will say? Okay, let's move ahead. Okay, problem 5 question is based on oxidation reduction chemistry. Problem 5, in the reaction CH3COH first underwent LH reduction or LiLH for reduction, then PCl5, and then alcoholic KOH. I think you should know about all the reagents, but let me tell you, LAH converts your acid to alcohol. PCl5 is going to convert
Chlorinating agent.
your alcohol to alkyl chloride by substitution. And you very well know that alcoholic QH is going to eliminate your HCl and will form olefin. Now can anyone tell me what will be answer here? I have written answer already. So,
Ma'am, it will be the first answer, ethylene.
but let's go one by one. Can you tell me product A? That will be CH3.
Methyl alcohol.
Exactly, CH3 CH2OH. Then CH3 CH2 Cl. After that CH2 double bond CH2. And this is nothing but your ethylene. So option 1 is most appropriate. Problem number 6. Compound A, C8H9Br, gives a white precipitate when warmed with alcoholic AgNO3. Then it is saying oxidation of A gives an acid which easily forms anhydride on heating. Identify the compound A. So see how to approach these type of questions. It is saying C8H9Br. C8H9Br. One method is you can find degree of unsaturation. Can anyone tell me formula for finding degree of unsaturation? C minus H by 2 plus, and actually this is not required, but for your information I am telling. Oh, okay. How many carbon are there? 8. Hydrogen? 9. Nitrogen? Nothing. But we have monovalent atoms in our reaction medium, that is bromine. So this is monovalent atoms. Bromine is monovalent, right? Plus it will be 8 minus 8 by 2 plus 1, that is 8 minus 4 plus 1. What it will become? 8 minus 9 by 2 plus 1. 8 by 2 4. I think we have made mistake anywhere. 9 minus 4, it comes 5. Okay, let me correct here. C minus H or monovalent atom by 2 plus N by 2 plus 1. Sorry, I am correcting it. Wait, let me erase this. Sorry, I got confused here. So now can anyone tell me degree of unsaturation? C8 minus 9 minus 10, okay, because one is hydrogen or any monovalent atom. So 9 plus 1 10. There is no trivalent atom like nitrogen here, so 0 and plus 1.
Ma'am is 4.
Exactly, 4. Now see, degree of unsaturation is how many double bonds are there in your molecule. So 1, 2, 3, right? And 1 for your ring. So total degree of unsaturation is 4, right? Like, but benzene is in all four option. So this strategy gets eliminated. Now what it is saying, compound A gives a white precipitate. White precipitate it will give off silver bromide. But you know that compound 2 gets eliminated because if silver bromide forms, it will form positive charge here. And you very well know that positive charge can't come on sp2 carbon. So option 2 gets eliminated. Now we have three options. In all three options, compound A can give white precipitate, right or not? Because a formed carbocation will be resonance stabilized. But in next line, what it is saying, oxidation of A gives acid. Okay, we should know this thing that if we have R group on our benzene ring, and if it is getting oxidized by your KMNO4 or any oxidize, sorry for this, or any oxidizing agent, it is going to give benzoic acid. So now can anyone tell me? And last it is telling it easily forms anhydride on heating. So according to you, which option should be most appropriate? In option 1, both the acids are going to form here. In option 2 at para position. And in option D it is going to form at ortho position. When two molecules of acid are heated, they undergo decarboxylation and forms anhydride like this. So in option D, both the groups are ortho to each other, therefore they are easily forming anhydride. Therefore option 4 is most appropriate. Anyone have doubt in this question? I will explain again.
Ma'am, I have a doubt.
Yeah, ask.
Is there any kind of intermolecular bond right there on the fourth option?
No, intermolecular no. See, a- anhydride is difficult to form, right? Because it is having one carbon bridge in between. And para can't react at all. Okay, let me explain you by another way. Wait. Actually, it is not changing. Okay, now it is good. See, let's say you have RCOOH and write another molecule COOH. Okay, on heating, one molecule of H2O gets eliminated. And what with it will form RCOOCOR. So this is basically reaction when two acid comes, they forms anhydride on heating. Okay. But when both the acids are ortho to each other, they can easily come together and can lose one molecule of water and can form anhydride. Now you have understood.
Yes, ma'am.
Okay. So can we move ahead? Okay. So problem 7 is based on ozonolysis. Which compound would give me 5 keto 2 methyl hexanal upon ozonolysis? Now let's first draw this 5 keto 2 methyl hexane. So just draw 6-member ring, sorry, 6-member chain, 1, 2, 3, 4. Okay, hexanal, it means aliphatic aldehyde is there. Am I correct? 1, 2, 3, 4, 5, 6. 2 methyl, 1, 2, 2 methyl. 5 keto, 1, 2, 3, 4, 5. So this should be your product. Among these four options, whose ozonolysis can give me this product? Can anyone tell me? Before solving, let me tell you, if you have this type of alkene in your medium and it undergoes ozonolysis, it cleaves this and just write carbonyl instead of, let me again clear. If you have this alkene, you have ozonolysis reagent, just cleave from between and form these two carbonyl. Right? Now can anyone try this question? We just have to cleave this alkene and put carbonyl there.
I think the first option.
First option, okay, let me check. Okay, this is your cyclopentene. So CH3 will be as it is and it will form this and this will form this. So you are saying first option, right? So if I check, see, first option gets eliminated. Why? Because your product have aldehyde and in first question, you first option number A, you are getting ketone at both the terminals. Understood? Why option A can't be correct?
No, ma'am, can you please re-explain?
Okay, let me explain again. It is saying or asking which compound among these four options would give 5 keto 2 methyl hexanal. So this is your 5 keto 2 methyl hexanal. Okay, hexanal means aldehyde is there. But in option number 1, if we cleave, we got ketone at both the terminals. But our product having aldehyde in one of the terminal. Now you have understood.
Yes, ma'am.
Hmm. In option number B, if we look at, it will form this. See, now you have one hydrogen on alkene. Is this can be correct option? Let's see. 2 methyl, 3, 4, 5 keto. Yes, option B can be correct. Now, can anyone tell me why options C and D are not correct? Draw product and tell me what product you are getting. I'm also drawing. You guys also start. Here you are getting methyl substituent at 1, 2, 3 position, but we want methyl at 2 position in question. And in option number D, if it underwent ozonolysis, it is getting 1, 2, 3. At 3 position methyl is again coming, so option D also gets eliminated. Anyone have doubt in this question? Yes, Jayashri, Sai, Lokesh, have you understood this question?
Yes. Yes, ma'am.
Okay.
Yes, ma'am.
If you have any doubt, you can interrupt and unmute and ask. Okay. So let's come to problem number 8. It is asking in the reaction scheme shown below, QRS are major products. The correct structure is of S. I think they are asking structure for all. So can anyone tell me first reaction is which name reaction? Name reaction we can't say. Which organic reaction? Let me give you a hint. Electrophilic aromatic substitution. Second, this is Clemenson reduction. I'm just giving hint. This is your Grignard addition. Understood till here?
ma'am.
Okay. You also draw in your copy. Can anyone tell me what electrophile will form on reaction of this anhydride and AlCl3?
I think aluminum will gain one electron.
Okay, let me tell you. Wait. Okay. Can anyone tell me? Aluminium have one vacant p orbital. It will coordinate to which oxygen among these three oxygen? Right? We can write it like this, right? If I'm wrong anywhere, you can interrupt me in between. O Al Cl3. Now, since aluminum is having four bond, negative charge will come, right? Am I correct here or not? Or second option is one option is this one, and second option is your Lewis acid. AlCl3 is nothing but your Lewis acid, and it will bind here. Sorry, I have made one mistake. Now it is. According to you, which is more appropriate, this one or this?
Then the first option.
Okay, you are saying first is, and positive charge will come here. Yeah,
No,
you.
ma'am.
Yeah, you
No,
are. What?
just
Yes, you are absolutely correct here. And then what will happen? This bond will cleave. Okay, let me draw here. So we have to see all the possibilities, right? CO positive, and here what it will come? AlCl3 negative. So this is your electrophile. Have you understood?
Yes, ma'am.
Now tell me where electrophile is going to come in P. We have this position, this position, this position. Let me number this one, two, three. We can easily tell in P at
ma'am.
one electrophile can never come. Why? Due to steric
Yeah.
reasons. Now among these three options, I think so. Third position is most appropriate for this. Right?
Yes, ma'am.
Okay. So you just have to put your electrophile there. This is your tertiary butyl group. So what it will form? CO. Then how many carbon? Two carbon are there. One, two. Then your carbonyl. Okay, I've done mistake here. Wait. Hmm. One, two carbon and your, and after workup OlCl3 will become OH. Understood till here? Everyone?
Yes,
Nothing,
ma'am.
just electrophilic aromatic substitution reaction has been taken place.
Yes.
You understood now why this is wrong? Just draw and ask yourself which is more appropriate. So as Jayashree told, this is more appropriate and she was right here. So now what reaction is there? Clemmensen reduction. You should know that RCHO, you should have sound knowledge of all these reagents, right? Zinc HgHCl, it form alkane RCH3. So if this undergo Clemmensen reduction, what will be your product? 1, 2, 3. 1, 2, 3 और ये. Up to here it is clear, everyone?
Yes, ma'am.
Okay. Now can anyone tell me what H3PO4 is going to do? Just think. You may be wrong, no issue in that. Just try and tell. Let me erase, then I will tell. So till here we reach to 1, 2, 3 and this COOH. Okay. Now see, H3PO4 is nothing but your acid. Acid is going to protonate this, right? H2O will leave, positive charge will come here, and it will again do your electrophilic aromatic substitution reaction. Understood?
Ma'am, can you explain it again?
Okay. You have this acid in last step here from here. Till here it is understood, right?
Yes, ma'am.
Okay. Now you have H3PO4 in next step. H3PO4 will going to give H plus. Who will take H plus? This OH. And after taking H plus, positive charge will come here. Correct?
Yes, ma'am.
Okay, very good. Now, after removal of this H2O, this electrophile gets formed, and this electrophile is going again to attack here, your benzene ring, and it will form fused system. Let me count ring. One, 2, 3, 4, 5, 6. You can number for your reference. Okay. Sorry, we will number from here now. 1, 2, 3, 4, 5, 6. Okay.
Yes, ma'am.
And can anyone tell me where this carbonyl is going to come? Here. Just brush up your concepts for electrophilic aromatic substitution. You will get to know that this till here this step is correct. Right? Can we move ahead?
Yes, ma'am.
Okay. In next step, there is Grignard addition. In Grignard, what it will form? It will form OH and it CH3 got attached here, right? Because in Grignard, this is your carbanion going to attack this ketone, will form OH on hydrolysis, and this tertiary alcohol gets formed here. And on H2SO4 heat, H2O will leave and this OH, and it will form this type of system. So this is in which option? Option number D. Everyone got it? How I came to this? Let me explain you again. First, electrophilic aromatic substitution has taken place at this position. Then, under Clemmensen reduction, your ketone will reduce to alkane. Then, under H3PO4, again a protonation of this hydroxyl group will happen, and again electrophilic aromatic second electrophilic aromatic substitution will take place. Then addition of Grignard, And after that, at last, in H2SO4 heating condition, your H2O will eliminate and will result in formation of this alkene. If you have doubt, you can see this. Let me erase first. So this is here I have given solution. You can check again. Okay. Problem number 9. After looking at this question, can anyone tell me which type of reaction is taking place here? Name reaction. Start. Let me give you hint. This name reaction starts from A.
Ma'am, addition elimination reaction.
No. Okay, you are saying addition elimination. Addition then elimination. You should know for that. Okay, and let me. Okay, you should know that for addition elimination, you should have leaving group and ortho or para electron withdrawing group. Then addition elimination can take place. So addition elimination get cancelled. Now tell me. Today we are solving question based on carbonyl chemistry, right? This is nothing but your aldol reaction. Everyone knows about aldol reaction? Okay, let me tell. We have two molecules of this. In presence of base, first it is going to abstract proton from here and it will form enolate. Correct? We have another molecule of this since we are taking two molecules. This enolate will come and will attack this. Understood? And at last, under heating, H2O will leave, forming your CH3, CH3, double bond CH2, CO, CH3. This was quite recap for aldol reaction. Everyone got it or not?
Yes, ma'am.
Okay. So can anyone tell me in this question which is most acidic proton? Okay, let me number. From here proton abstraction is possible. From here proton abstraction is possible. Here and here. Correct? Both are ketones, so both have almost same reactivity. Now, from let's say if proton is getting abstracted from this position, here negative charge will come and it is going to attack this carbonyl. How many matlab, what number of ring will form here? 1, 2, 3, 4, 5, 6. And 6-member ring formation is feasible, right?
Yes, ma'am.
Okay, so let's attack in this way only. It will form OH, and as we have counted, it will form 6. 1, 2, 3. Second position, nothing. Third position, wait, we have done mistake here. Let's give again 1, 2, 3, 4, 5, and 6. Right. So 1, 2. Always start doing this type of question while numbering. Okay. Once you get expert, you can do. I have to rub this part. 1, 2, 3, 4. At 5 position, your ketone is there, and 6 position, your methyl group is there. Till now, it is clear. And the next step, it is giving that heat is there. Heat means elimination is going to take place. So this will be your product. Elimination will take place from where? From here, here or here. This will be most appropriate. Why? Why? This is having more hyperconjugation. Two hydrogen here, two here, two here, and one from here. So in total, six hyperconjugation are there. So this product is most stable, and this is option number B. Anyone having doubt here?
Ma'am, can you explain the part of elimination?
Okay, okay. See, let me redraw here. You have here OH, right? Now, for elimination of water, it can take proton from neighboring carbon only. So, three neighboring carbon are there. If it if H2O molecule eliminate from this side, it will result in formation of A. And if sorry, it will if it gets eliminated from this side, it will result in formation of A. And then if it gets eliminated from this side, it will result in formation of B. But among these two olefins, this is more stable. Why? Two hyperconjugation. But can anyone tell me among these two structure which is more stable? A and B. Here your double bond is in conjugation with this carbonyl oxygen. And here conjugation is not there. And we know that mesomeric comes before hyperconjugation. So I think more appropriate answer is A, not B. Because here double bond is in conjugation with this carbonyl. Now clear, Jayashri?
Ma'am.
Okay. Now again question comes for correct order of acidic strength of following carboxylic acid. 1, 2, 3, 4. So tell me. Okay. As I have told you earlier how to proceed this type of question. First, draw conjugate base.
The conjugate base.
Okay. Then what I have told you? See
We'll see
stability.
stability.
How? Size, electronegativity, reso, hyperconjugation or inductive. Okay. In first step, it will form this. In second, it will form this. Third, it will form. Fourth, it will form CH3, CH2, COO. Now let's apply these rules. Okay. Size is same as on all the size of what in which this carbanion is there. So only there are two possibilities. This negative charge will migrate on this oxygen and this oxygen only by resonance. So we have to see here. Okay. This group is what? SP. SP carbon is there. This is sp2. This is also sp2. So among all these three options, four options, this is sp3 carbon. What according to you, can anyone tell me electronegativity order of sp, sp2 and sp3? For hint, let me tell you, more the s character, more is your electronegativity. Now can any,
Then
okay, what?
then sp2 and sp2 is greater than sp3.
Exactly. So among these option, option 1 will be in front, right? Because all other are sp2. Because we have to apply these rules in order. Next is your resonance factor. So which is greatest in?
The third option.
Now before this let me tell you, this negative charge apart from going this way, O negative, है ना, it will form this. Okay, but this can also be come in conjugation with this ring. And I have told you earlier in earlier slide that same atom resonance is better than different atom resonance. Here, resonance can take place between oxygen and carbon, but in case fourth, resonance is going only to take place between these oxygen, right?
Yes, ma'am.
Correct or not? So
Yes.
now, can after listening all these arguments, can anyone tell me final order? Let me erase. So this is your answer. You can see. It is saying stronger will be acid when its conjugate base is highly stabilized, right? One is the most acidic and fourth is the least. Since CO2 negative is attached with an sp hybridized carbon in one and in fourth it is attached to sp3 hydrogen, right? So among one first and fourth things are clear. Let me change ink. So among first and fourth, first is ahead due to sp and fourth is at last. Among 2 and 3 it is saying third is less acidic than as electron donating group destabilizes the carboxylate anion. You should know that OMe is which group? Plus M group. Why? Because it can donate its electron density inside the ring. If it is donating electron density inside the ring, it will decrease electrophilicity of this carbon and hence stability will be less. So among these two options, this is more acidic. So order will be 1, 2, 3, 4. Is there doubt? See, for acidity, minus M or minus I is better, while plus M and plus I are inversely proportional to your acidity. So you should know directing effects of all the groups. First, we have segregated based on electronegativity. That you have already told that sp is greater than sp2 than sp3. Then we have solved on basis of resonance. Resonance is there, but this OMe is plus F. If instead of OMe here NO2 was there, then NO2 will come ahead of this. Okay.
Yes, ma'am.
Okay. So option B is correct. In problem number 11, it is asking total number of carboxylic acid group in product P is. First, you have to tell product P, then tell me how many carboxylic acid groups are present in product P. First step, can anyone tell me what will happen?
Elimination reaction.
In first step, elimination, from where you will do elimination? See, second step is nothing but your ozonolysis. Let me tell you. First step is COOH, COOH. On hydrolysis, it will form this. Okay, first on hydrolysis. Then it is saying heating condition are also there. In heating condition, tell me what will be fate to these two carboxylic acid.
Hydras.
What? See, anhydride was already there in starting material. On here heating, COH minus 2 CO2 molecule will leave. Correct. So this is going to be your product. After ozonolysis, this bond is going to cleave. Now since we have H2O2 also, it will further oxidize these aldehydes to acid. H2O2 is your oxidizing agent. Remember this. Now tell me how many carboxylic acid groups are there? You have done one mistake here. On removal of these two acids, here alkene will also form. So on ozonolysis, it will form like this. So in total, we are going to have four carboxylic acid group in our product. So let me draw final product for you. Understood? Jayashri, you got confused in this question, right?
Yes, ma'am.
Yeah, I know. Where is there confusion? Tell me.
Ma'am, as I remember, just 2 or 3 slides
Back.
before you and
Mhm.
you told us that there is an anhydrous forming
Yes, and not anhydrous, anhydride.
anhydride.
This is anhydride. I know you are saying correct, but see, if it is again going to form this anhydride, then why it is starting from this? It is starting from this and will again form anhydride. That is not the case, right? In heating
Okay.
condition, decarboxylation is also taking can also take place.
Yes, ma'am.
And after decarboxylation, alkene will form. Both sides you have to cleave, and H2O2 is your oxidizing agent. Clear?
Yes, ma'am.
Okay. So here also it is giving. Wait, we were wrong here. Let's see. It is income. In answer, it is showing that first it underwent hydrolysis as we have done it. On heating decarboxylation, both of the it is starting from where? Okay, here. Both of the carboxylic acid group gets eliminated on heating and then oxidative ozonolysis, and then in H2O2 it is oxidized. Sorry, so here answer will be 2. I was wrong. That double bond will not come on decarboxylation. I was wrong there. Okay, sorry for that. Jayashri, can you understand from this?
Yes, ma'am.
Now clear na? On heating, just decarboxylate. Just remove these two carboxylic acid.
Yes, ma'am.
Earlier I was right, but then I got confused actually. So tell me in this question. In the following reaction, compound Q is obtained from compound P via an ionic intermediate. Tell me degree of unsaturation of Q. This you can take it as your homework. I will ask you next week. Okay. I hope answer I have given answer. Please don't see answer, just solve and then check your answer. Okay. Here it is asking reagent which can be used to bring following transformation. If we look at clearly, this is your acid group and this is your aldehyde. Here only aldehyde is reducing, not acid. So can anyone tell me which reagent is best among all these four? H
Ma'am,
H2 nickel is used for hydrogenation of olefins or alkynes. Among these three, can you tell me? Let me tell you, in nucleophilic reducing agent, we have NaBH4, ZnBH4 or zinc borohydride, and LAH. And if we see reactivity wise, this is a aldehyde, ketone, ester, acid. ठीक है? Okay. Aldehyde is more reactive, so, and reactivity wise, LAH is more reactive in reducing agent, and this is nucleophilicity order. Let me draw here. See, more electrophilic is your carbonyl carbon, more is the reactivity. Are you with me? Right?
yes, ma'am.
In ketone, alkyl group is there instead of H, and alkyl group is plus I group. It is going to decrease its electrophilicity. So among aldehyde and ketone, aldehyde is more reactive for this reaction. And if we see in this ester, in books it is written that here oxygen minus I will come into picture. So it is going to increase. Plus M group is also there, I know, but apart from instead of plus M, I group minus I effect is operating. And in acid, OH is plus M. It is going to decrease its electrophilicity. Therefore, reactivity wise, first aldehyde come, then ketone, then ester, then ester. Okay. Here they want to reduce only your aldehyde. So they have to use mild reducing agent. Mild reducing means that have somewhat lower reactivity. Because LH or lithium aluminum hydride is going to reduce both the carbonyl. It will reduce this to CH2OH and this also. So now can anyone tell me which option is correct?
Ma'am, option C.
NaBH4. Option C. Correct? Who all are there in class? Let me see. Okay, let's move to next question. Which of the following reaction will form an epoxide in presence of per acid such as MCPBA? Do you guys know how MCPBA function?
No, ma'am.
Okay, so first I will tell you. Basically, if you have your alkene in your reaction medium, MCPBA is meta chloro per benzoic acid. Okay. For for present case, you should remember in presence of MCPBA, epoxide forms. Okay. So in which case it is can form on alkene. So it was simple question, but you should know mechanism for this. For mechanism, I am giving you hint. You have to draw, but let me give you hint how to draw. It is not changing actually. Yes, now it is working. So let me draw metachloroperbenzoic acid for you. When per comes, it means one oxygen is more. This is your perbenzoic acid. Metachloro, meta position chloro. Okay. When we have such peroxide type molecule in our medium, you can see that resonance will take place between these two oxygen atom 1 and 2. Wherever you have doubt, you can stop me and ask, okay? So this is proximal near carbon, this is distal carbon. Distal carbon means this, sorry, not carbon, oxygen. So distal oxygen is quite electron deficient. Why? Because this carbonyl oxygen is pulling electron density of this oxygen. So oxygen number 3 will be electron deficient, right or not? And we know that our olefin is electron rich. It is having electron density here. Okay. So it is going to coordinate with this oxygen. Which oxygen? This electron deficient oxygen. And you have this OCO. O. Understood this type of transition state. Let me redraw here. Wait. This is called butterfly like transition state. This will form like hydrogen bonding type species. This is your pH, metachloride substituted. One, two, three, four, five. Have I done anywhere mistake? No, no. Okay. So you can see that, right? Nothing. This hydrogen is going here. This will come here, and this oxygen bond will break, and it will form epoxide. Correct. Understood little bit.
Yes, ma'am.
If you will see again, you will get to know how it is working. Basically, this is your electron deficient oxygen. Okay, it is going to attack on your olefin, which is electron rich system, and then it will result in formation of epoxide. Let's move to next question. Problem 15. An ether is more volatile. Volatile means an ether is more volatile. Volatile that flew off in air like water. Okay. An ether is more volatile than an alcohol. So your ether is this. It is saying, let's say we have methyl O methyl or CH3CH2OH. They are saying these two functional group have same molecular formula, right? But this is more volatile. Why?
Alcohol,
Can anyone
hydrogen bonding,
suggest a reason?
hydrogen bond,
Exactly. Who has answered this? Can you tell me your name?
hydrogen bonding is there in the alcohol.
Alcohols, right? Let me tell
That is
you.
the strong,
Sin.
strong bond.
Yeah.
That's why
See,
it's
more
most stable.
exactly. More the
Ether is there is no hydrogen bond,
more
easily evaporate in space.
yes. More the number of interactions between your molecules, it will prefer to be together. Understood what I want to say? See, these alcohol molecules are binded to each other in intermolecular fashion via hydrogen bonding. So it forms a cluster of these alcohol. So there is no possibility for their becoming volatile. But here there is no interaction between other molecule of ether. So it will become volatile. On giving heat, it will change. It will uh, basically we can say that it will try to remain its in gaseous form, because as we know in gaseous form molecule are at distance to each other, but here it will love to be in liquid form due to interaction between two molecules of alcohol. I hope you got it right. Okay, so I think this is your oh, many questions are there. So problem number 16. Which of the cation A to D is the least likely to be intermediate in the following reaction? Which type of reaction is this? Have you listened about pinacol rearrangement? Pinacol, pinacolone? No.
Yes, ma'am.
You have listened, na?
Yes, ma'am.
Okay. So first step is protonation, right? Clear till here? Now now removal of water, and it will leave positive charge here. Correct or not? Now one of the methyl group is will migrate as CH3 negative, and positive charge will come here, migrate to nearby carbon. Can anyone tell me why this methyl group has been migrated? Because for carbocation stability we have to see plus M, then aromaticity, then resonance, then your hyperconjugation, then your inductive. Right?
Yes, ma'am.
Understood till here, right?
Yes, ma'am.
Okay. So one possible intermediate is this. Can we find this and see what is question? Which of the cations A to D is least likely to be an intermediate in the following rearrangement reaction? Least likely. Tell me which one is least likely. See this one.
But D.
We can't have two positive charge in our molecule nearby to each other. Correct? D is quite possible. Why? If you have this species, this can mesomerically stabilize it, right? And can lead to this. Right or not, Jayashri?
Yes, ma'am.
So this can be possible, but option number B in this is least possible. Right? I hope you guys understood.
Yes, ma'am.
Okay. In next question also it is type of pinacol rearrangement. We can't say. Can anyone tell me on first step what it will form? It is asking
Ma'am,
what is the main final product of the following diazotization of amine. We should know that aliphatic amines on reaction with NaNO2 HCl it form N2 positive diazonium type. You have studied na, this type of reactions? Yes or not? Not. This N2 group will leave
yes, ma'am.
N2 group will leave and form carbocation here. Now you know, as in previous question, why carbocation form here? Due to plus M effect of OH. In same way, carbocation wants to form here. For that, we have to break this bond. If we break this bond, Here it will come negative, and bond formation will take place here, right? I am showing for understanding purpose. Otherwise, you have to show like this. Okay. How many number? How much? One, two, three, four, five, six member ring is going to form.
Ma'am,
Huh? Ask.
ma'am, is this a rearrangement?
Yes, this is also rearrangement. Type of pinnacle rearrangement you can say, but not pinnacle. Because here diazotization is taking place. In
Okay.
pinnacle, both oxygen are there nearby to each other, not oxygen, hydroxyl. And at last only oxygen lone pair will come and will form ketone there. So option number D is correct. Any problem in this question? I can explain again, you can ask.
Ma'am.
No, na? Okay. Now, this question you have to try. This is your homework. Same as problem number 60. Just try. Hint is first what it will form. Can anyone tell me? One of the OH get protonated. Since H plus is there in medium, right? In next step, what it will form? Carbo cation, right or not?
Yes, ma'am.
Then ring expansion will take place. Why?
Yes, ma'am.
Because positive charge want to come here. For that, let me write. For your understanding purpose only, I am writing like this, and it will form positive here. If this bond breaks, this, okay, negative will come here and will form this bond. How many number? One, two, three, four, five member ring gets formed here. Till now, it is clear.
Ma'am,
Ask.
is forming five ring
So
is
I have drawn five now. One, two, three, four, five. This carbon ion. If we
no, ma'am.
break,
I'm just asking. Forming a five ring carbon is it's unstable.
no, let me tell you. Six member is more stable ring than five, then four. Why? See, you know an sp3 carbon, tetrahedral carbon. Okay. Can anyone tell me which is what is bond angle here?
108.
Okay. Approximately 107 degree or 108 degree. When you are forming cyclobutane, this sp3 carbon is having angle of 90 degree. So very much angle strain is there, right? So to get relief from this strain, these type of ring expansion take place. Understood?
Yes, ma'am.
Therefore, it is changing from 4 to 5. And now
Yes,
just
ma'am.
as positive charge is near to your oxygen, it will mesomerically stabilize it and it will form ketone. Correct?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So this I have put for your summary. You should know all the reaction of your acid. Wait. Okay. How you can change your acid to acid chloride in presence of SOCl2, PCl3. This you should remember. Okay. In presence of sodium metal, what it will form? Sodium salt of this acid. NaOH also it will form. So you should remember all these reaction, right? So this was summary of reactions of carboxylic acid. You you can check or read in your notes. I will upload notes today. Thank you. So thank you students for listening me. You can leave now.